Hello everybody, welcome back. We are continuing with chapter 3. Section 3-4 will be the last section of this chapter, and it's a short one. I don't want to spend too much time on it. It's about piecewise defined functions. From the name of it, that means when you have functions that are in pieces. For example, if you look at this example in the book, example 1 on page 287, notice how the function is. You have a linear part and you have a quadratic part, but they're in pieces. Now, if you look at the way the function is written, notice there are two parts to the function, obviously. You have the linear part, which is in slope-intercept form. So you have negative 2x plus 10. So the y-intercept is 10, and it's right there. You have a negative slope of 2 over 1. So you go 2 units down, 1 unit to the right. 2 units down, 1 unit to the right. And you draw that line. But look at the restriction on the domain. The domain, or the x values, are just between 0 and 3. So your x values, this is your x, these are your x's from 0, 1, 2, 3. You cannot go beyond this. So that part of the line was erased. So that's why it stops right there. Now this one is a quadratic function because the degree is 2 and the leading coefficient is a negative. And so that's why the parabola is opening down. Notice the red part is opening down. And look at the domain. It's from 3 to 7. From 3 to 7. So that means starting here. So this part of the graph is erased. So that's an example of a piecewise defined function. Let's take a look at this example number 3. A function is given to you. Again, you have a quadratic function, which is in vertex form because the h and the k are obvious, and you have a constant function, just f of x, which is your y equals to 3. So let's do this first. So remember, your leading coefficient is negative. Happens to be negative 1, so you know your parabola is opening down. Your h is positive 3. Remember from the last video we talked about we always switch the sign on h. And your k is positive 12. So that means your vertex, which is the maximum point because the parabola is opening down, it's going to be at positive 3 and positive 12. So there's your vertex. And then you draw the graph using table and so forth. But then you have to look at the domain restrictions, which is between 0 and 6. So if x is 0, your graph is intersecting the y-axis over here. That's your y-intercept. All the way to 6, right there. So that's your domain restriction. So notice the graph is erased beyond those points. Now, look at this open circle and look at this closed circle. Why do we have those? This goes back to the restriction. X cannot be 0. Cannot be 0. X is just greater than 0. So that's why you have an open circle there. X can be 6 or less than 6. So 6 is part of the solution. So that's why you have a closed circle. So basically, this is what we get for the parabola. Now, if you go back to this, y equals to 3, that's a constant function. And y equals to 3 is a horizontal line, if you remember from chapter 1. So it's y equals to any number, it's a horizontal line. So you see, you go to 3 on the y-axis, you draw a horizontal line. Do we have a restriction on it? Yes, we do. X is only greater than 6. So if this is 6, you can only have greater than 6. That means this way. So we're going to erase those, and this is your final product. Okay? So I just want to give you an example of piecewise function. And then there's another good example of modeling that I recommend you read it. Example 7 at the bottom of page 291. And it continues on the next page. And you got to come up with a function and then graph it. And you get it. And the functions happen to be two linear functions. So make sure you read it and then take a look at how they did the example. It's a very good example. Okay, so now let's move on to chapter 4. Chapter 4 is on polynomial and rational functions. So we are going to do section 4-1, 4-3, and 4-5. Now 4-5 is in conjunction with section 3-2, or part of 3-2. So I'm going to refer back to that. Okay, so in section 1 of chapter 4, basically we are graphing quadratic functions. So there are two ways of graphing quadratic functions. We already, well, let me get some examples going here. We already talked about what we call the vertex form, right? If you guys remember. So if you have the vertex form, looks like this. We talked about that in the last chapter. Why do we call it vertex form? Because the h and the k are the coordinates of your vertex of the parabola. So if you have it in this form, you automatically know where your vertex is. That's why we call it the vertex form. And then we have the standard form, which is this way. Okay, so I'm gonna concentrate a little bit on the standard form. Okay, so again, for both of these forms, whether you have vertex form or standard form, if your A is positive, you know your parabola is gonna go up, opens up. If your A is negative, your parabola is going down. We already knew that, and both times, in both situations, we have a vertex. And we have the axis of symmetry that always passes through the vertex and splits the parabola into two equal parts. Okay. Now, if your equation, quadratic equation, is in this form, it's not so obvious where the vertex is. So there's a formula for that to find the vertex. Well, the x value of the vertex is obtained by x equals negative b over 2a. Where do you get b and a? Right here, not the bank. Ha ha ha. Okay, and how do you get the y value? For the y value, just plug the x value into the equation. Okay, so now this one also gives you the equation of the axis of symmetry. So this is not only the x value of the vertex and equation of axis of symmetry. Okay, so this is all of it, and that gives you the y value of the vertex. So the equation of the axis of symmetry is always x equals to h, whatever your h value is, and this will give you the h value. Okay, and since the axis of symmetry is vertical, the equation is always x equals to a number, like we did in chapter 1. Now, if you have it in vertex form, it's very easy. If I ask you what's the equation of the axis of symmetry, whatever your h value is just that, x equals to h. Okay, so, oh, and what do we call this point if your graph opens up in addition to vertex? We call it the minimum because it's the lowest point on the graph. We call this sucker the maximum because it's the highest point on the graph, as well as the vertex. All right, so let's do some examples. Let's see. I have example number, okay, so let's do this one. So what if we have this example? I give you g of x equals to 2x squared plus 8x plus 3, and I want you guys to graph it. Okay, so let's dissect it. So we have a equals to 2. So a is a positive number, so it opens up. Now, how do we know we have a parabola? Because the degree is 2. It's called the quadratic function. So the parabola opens up. Okay, we know that. Let's calculate the vertex. So the x value of the vertex is negative b over 2a. What's my b? It's 8. So you'll have this all over 2. A is 2 as well. So you have negative 8 over 4, which is negative 2. So the x value of the vertex is negative 2, which also happens to be the equation of the axis of symmetry, x equals negative 2. Now, how do I find the y value? You plug this in place of x. So you have 2 times negative 2 squared plus 8 times negative 2 plus 3. Don't forget your Aunt Sally. You cannot multiply these guys. You got to raise it to the exponent first. So y equals to 2 times 4, because negative 2 squared, minus 16 plus 3. Okay, so that's 8 plus 3 is 11 minus 16. That gives you a negative 5. So your vertex is located at negative 2, comma, negative 5. Okay, so I'm going to locate that. 1, 2, 1, 2, 3, 4, 5. So there's my vertex. There's my axis of symmetry, which has an equation x equals negative 2. You see it crossing the x-axis at negative 2. The rest is the same. So you just make a little table. We already have this point, which is my vertex. Now pick a point on the right side of the axis of symmetry, pick a point on the left side. And I recommend you go the same distance on both directions. So let's pick negative 1, and then let's pick negative 3. Because that way, if you go the same distance, the y values are the same, because a parabola is symmetric. So, okay, so if I plug in negative 1 into my equation, so g of negative 1, you don't have to write it like that, but so that's 2 times negative 1 squared plus 8 times negative 1 plus 3. And what do we have? Negative 1 squared is 1. 1 times 2 is 2 minus 8 plus 3. 2 plus 3 is 5 minus 8. It's negative 3. And voila. So this is negative 3. And this will be negative 3. Because the values are the same distance away from the axis of symmetry. So just plot it, negative 1, and negative 3, and negative 3. Okay, here we go with my bad handwriting and drawing. Oh, didn't pass through the point. Okay, so we'll go something like that. That's not the best. Okay, now if the problem asks you what are the x-intercepts, what do? You put a 0 for y and then solve for x. You can use factoring, you can use quadratic formula, and so forth. What if I ask you, what is the y-intercept of the graph? Well, the y-intercept is when x is 0. So if you put a 0 here and a 0 there, what happens? These guys drop out. You just get g of x equals to 3 or y equals to 3. So that means it's passing the y-axis at 3. And whatever these points are, those are your x-intercepts. Okay, so that was one example. Let's see if you have another one. I'm picking from the book. Supply and demand. This is a good example. Number 8 on page 342. So make sure you look at the section, read them. You don't have to read everything, but look at them, especially look at the examples and how they solve them. Okay, so if you read the problem, it says when a popular running shoe is priced at 80 bucks, the shoe warehouse will sell an average of 96 pairs per week. Based on the sales of similar shoes, the company believes that for each decrease of $2.50 in price, 4 additional pairs will be sold. Okay, so construct a function that models the store's revenue at various prices. So here you go. This is the equation for the revenue. You FOIL those or you multiply them, you get this. And what is it? It says in part A, still says, what is the maximum possible revenue under these conditions? Okay, so let's look at that. I'm not too concerned about that part because you can see it why. But I want to look at the other one, the other part. Your model, quadratic model, is this. Revenue is negative 10x squared plus 80x plus 7,680. And it's asking you, what is the maximum possible revenue under these conditions? Okay, so what does x represent in this problem? Okay, so let's look at the solutions on A. This is solutions. So it says, based on the given price and sales figures, the store has a current revenue of $80 times 96. That's 7,680. If you let x represent the number of times the price is decreased, we get this. So x is the number of times that the price is decreased. So if I want to get the maximum for part A, it says what price should be charged to obtain the maximum revenue. I'm sorry, sorry. It says what is the maximum possible revenue under these conditions? Maximum possible revenue. So is this parabola opening down or up? It's opening down because this is negative. So we know it's going to be something like this, right? So the vertex is the maximum price, and this is the maximum number of times, x. So basically the coordinates will be x, r, x. Okay, those are the coordinates. So how do I find x? Well, for the maximum or for the vertex, if it's in standard form, you say x equals negative b over 2a, which is negative 80 over 2 times negative 10. So that's negative 80 over negative 20. That gives you a positive 4. It has to give you a positive value. Otherwise, it's not going to be correct. Okay. So that's 4 times. Now, it says what price should be charged to obtain this maximum revenue. That means what is this revenue at this point? So what do you do with that 4? You want to find the y value, so you plug in the 4 over here. Okay, so if you plug in the 4, you get 78. So basically the revenue at 4 is negative 10. 4 squared plus 80 times 4 plus 7,680. And if you do the calculation, according to the book, the price, the maximum price, will be this. Okay? All right. And then the second part of it, if you read this, I highly recommend you look at this example. It says, what is the cheapest price the manager could charge while still bringing in a monthly revenue of at least 7,000? Okay, so look at what they did. If the revenue is 7,000, and you put it right there, what happens? You can simplify this equation to this. Okay, and then now this equation is not factorable. This equation is not factorable. So we can solve for x by using the quadratic formula. So the results indicate that to keep the revenue of at least 7,000 per week, the price must decrease by no more than 13.2. Okay, well, obviously this value is not acceptable because it's negative. But we use this value and $33, the negative solution, obviously. The selling price should be kept at 47. Okay, but anyways, those are the little details of the example. But please look at that example. It's important. All right, page 346. I was going to do number 34, or at least look at it. Maximum profit. The profit, it says the profit for a manufacturer of a collectible grandfather clocks is given by this function, where P of X is the profit in dollars and X is the number of clocks made and sold. Find the y-intercept and explain what it means. Okay, so how do we find the y-intercept? So the profit equation is given to you, the profit equation is given to you by negative 1.6x squared plus 240x minus 375. So it says, what is the y-intercept? So part A, what's the y-intercept? So what do we do? Take a look at it for a second and tell me, how do we calculate the y-intercept? What does y-intercept mean? Y-intercept means when the x value is 0, right? So if I plug in a 0 here and a 0 there, what happens? These guys cancel out. So the y-intercept is 0, negative 375. That's my y-intercept. So what does that mean in the context of this problem? Well, what does X represent? X represents the number of grandfather clocks that are made. So if the number of grandfather clocks that are made is 0, that means you're not making any money. You're actually losing money. So you're going to lose $375. That's what it means. Okay, find the x-intercept and explain what they mean in this context. Okay, so the x-intercept. Again, x-intercept is when this is 0, your y value. So 0 equals negative 1.6x squared plus 240x minus 375. So I'm going to solve this equation by quadratic formula, because factoring it is impossible, or extremely painful, I should say. All right, so what am I solving for? X, my b is 240, so negative b plus or minus square root of 240 squared minus 4 times a, which is negative 1.6, times C, which is negative 375, all over 2 times A. Okay, so that's how you solve for X. Now, if we solve that according to the book, you get this. Obviously, you get 2 values. Sorry, that's a 0. Okay, so it says no profit will be made if you produced 2 or less or more, or 148 or more. So these are your X values. These are the number of grandfather clocks that are produced. So if you produce less than 2, you're going to get a profit of 0. If you produce more than 148, you're going to get a profit of 0. So you better stay within those 2 limits. Okay? Again, this is problem number 34 on page 345. And my pen is dying. Interesting. Okay. Let me get another pen. All right. And then part C says how many clocks should be made and sold to maximize the profit again. To maximize. So is this opening up or down? This is opening down. So because A is negative. So if I want to maximize the profit, I want to find out where my maximum point is. So how many grandfather clocks do I have to sell? So I got to look at the X value at this point. How do I find the X value? X equals negative B over 2A. Why? Because it's in standard form. Okay, so what's my B? 240 becomes negative 2 times negative 1.6. So if you get our calculators here, times negative 1.6, and take the reciprocal times 240, you have 75. So X equal, and you have to get a positive answer because you're calculating number of grandfather clocks. So if you sell 75 clocks, you make the maximum profit. And then the last part is what is the maximum profit? So all you have to do is plug in 75 in place of X and evaluate the profit. Okay? All right, I think I'm going to stop right here and continue in the next video.